Hi, welcome to 2019, our first set of video notes for the new calendar year. I wish all of you guys a happy new year this 2019. You have an exciting year coming up as you finish up your 8th grade year and then you go off and start as freshmen at the high school. So very exciting. And so let's go ahead and make this last semester of algebra a good one. So we're going to start this video off with talking about something called geometric sequences. Let's go ahead and start by defining it. So the definition is a sequence of numbers in which the ratio we'll use lowercase r to signify ratio remains constant. A quick reminder about the word ratio. Ratio is another word for fraction. And to find that, we would, divide the top by the bottom. So the common ratio, though, we're going to find that by dividing each term by its previous term. So found by dividing each term by its previous term. If you want to think about it, it would be A2 divided by A1. So the previous term divided by each term divided by the previous term, okay? So if you don't already, go ahead and grab a calculator. So we'll have a calculator and we'll go ahead and get started. So we're going to determine if the sequences are arithmetic, geometric, or neither. If it is a sequence, we're going to identify the common difference or common ratio. So a quick reminder, arithmetic sequences, we did this back in our linear functions unit, and it was finding the common difference, how much everything adds or subtracts by. So let's go ahead and start with number one. Number one, we would take 2, 10, 50, 250. We would take the term divided by the previous. So 10 divided by 2 is 5. Okay, 50 divided by 10 is 5. So we notice that the sequence here is we're going to multiply each number by 5. So this is a geometric sequence and the common ratio is 5. So let's go ahead and put that in here for number one. So this is a geometric sequence and our common ratio is 5. Let's try this again for number two. So number two, if I would do 45 divided by 135, and I see it's 0.33 repeating. So the other way to think about this, to go from one next term to the other, we would divide by 3 each time, but we want to make sure that we are multiplying, not dividing. So to go from 135 to 45, we would multiply by 1/3. Not our repeating decimal, okay? So if you think about it, 15 times 1/3, we do get 5, and then we can kind of double check as we keep going. 45 times 1/3, we get that 15. So this, again, we're multiplying each term or dividing each term by the same number. So this is a geometric sequence. And our common ratio is 1/3. So a quick clue, if your numbers are increasing, you're going to get a value that is greater than 1. If your numbers are decreasing, you're going to get a value that's less than 1 but greater than 0. So that means that it is going to be a fraction. So let's go ahead and we'll save the rest for next time I see you in class, okay? Let's try geometric sequences here real quick. So given the geometric sequence, we're going to find the next 3 terms. So we just have to think about, to go from one number to the next, what is our common ratio. So we go from 7 to negative 21 to 63, okay? Or we can think about negative 21 divided by 7, 63 divided by negative 21. Each time what we're doing is we are multiplying by a negative 3. So if we continue this pattern, okay, and so again, using our calculators to help us, 63 times negative 3, we get negative 189. Negative 189 multiplied by negative 3, we get 567. And then the last one, again, you guys probably aren't seeing what I'm doing here with the calculator, 567 times negative 3, we get that negative 1,701, okay? Let's go ahead and try number 8. So number 8, the same idea where we're going to find that common ratio. So notice how my numbers are getting smaller. With it getting smaller, we know that we are going to be multiplying by some fraction, okay, to come up with that. So we can go ahead and do 768 divided by 3,072. Okay, and we get a quarter. Okay, we know 25 hundredths is the same thing as 1/4. The other thing, we can just check our math where we are doing 3,072 times 1. Don't forget ABC gives us our fraction, and it does work. So just checking our work there real quick. So lots of ways to kind of come up with that. So we are multiplying each term by 1/4. So if I take 192 and multiply that by 1/4, I get 48. 48 times 1/4, okay, is 12. So that's some of that mental math. 12 times 1/4, we get 3. Okay, and we can keep going from there. And then we'll try 9 and 10 next time I see you in class. The next thing that we're going to do is we are going to be talking about both the recursive and the explicit formula for geometric sequence. So we'll start with the recursive formula. We'll go ahead and write down the terms. So A sub 1 is your first term, and R is your common ratio. And so the formula here is A sub n is equal to R times, and then this is in parentheses, A sub n minus 1. So all this means is you're going to multiply it by the previous term to find the next term. Okay? So let's go ahead and do example 11 together. So for example 11, my first term, so you will always have to write down your first term, is 7. My common ratio, well, we already found this. If you take a look, I chose these 4 examples to match what we have up here, just to make things go by quicker. So we've already established that we found the common ratio is -3. So I'm going to just go ahead and recopy that. And then I'm going to go ahead and substitute this into my recursive formula. So it's A sub n is equal to -3 parentheses A sub n minus 1. So the way this works, the way this formula works is, and we'll use the calculator to kind of check here. My first term is 7, okay? And I want to find the next term. So let's say term number 2. I already know the answer, but to find term number 2, what I'm going to do is I'm going to take -3, multiply it by, it would be 2 minus 1 is 7. And I get -21. If I want to find the third term, -3 times, to find the third term, it'd be 3 minus 1, which is 2. That's my second term, so -21. And so it works, okay? So I want you to make the connection of what we're doing up here, where all we did was multiply by the common ratio by the previous term to get the next term. That's what recursive formula is, okay? It's just a fancy way of continuing a pattern, okay? Let's go ahead and do number 12 real quick. So we need to write down the first term. The first term is 3,072. Our common ratio, we established that from the top here, is 1/4. To write this in the formula, A sub n is equal to r times 1/4. Oh, I don't know why I have the r. We're using 1/4 for the r, so hopefully you're using a pencil. Fix that little bit of a typo, and then we have a sub n minus 1. Okay, so it is just, like I said, the algebraic way to write the formula. It is something you do need to make sure you have memorized, okay? And so hopefully you figured out at this point when I tell you to make sure you have something memorized, you will be required to do that on your own on the test. Okay, let's go ahead and flip it over. And so what we're going to do is we're going to go ahead and get started with the next kind of geometric sequence, which is your explicit formula. So your explicit formula, same thing previously, where a sub 1 is your first term. We do need to know that. And then your r is your common ratio. But we do have a different formula for this one. It is a sub n is equal to a sub 1, your first term, times r to the n minus 1 power. Okay, so let's go ahead and apply this for 15. So for 15, it says write the rule for the nth term, then find a sub n. So this is going to be two things that we want to make sure that we're doing, and you'll see that I require the same thing for the homework. So for number 15, a sub n, again, we're just using substitution to substitute. 3 is our first term times our common ratio. So let's figure out what our common ratio is. We go from 3 to 9 to 27. We multiply by 3 each time. So my common ratio is 3. So 3 to the n minus 1 power. Okay? So this right here, where I said write the rule for the nth term, that's what I'm talking about. Then we want to find the 7th term. So a sub 7 to find the 7th term. We're going to go ahead and use that rule that we just established. Our first term is 3, the common ratio is 3, and then it's 7 minus 1, okay, to find the 7th term. So just working this out a little bit, 3 times 3 to the 6th power. And then this is where you can just go ahead and substitute everything into your calculator. This is what I want you to do. Order of operations, you have to do exponents first. So it's 3, this button, to the 6th power, hit enter, times 3 to get our final answer of 2,187. Okay, let's go ahead and try this again for number 16. So I'm going to move this over to the other side. So number 16, we're going to start by writing that rule. The rule is a sub n. My first term is -4. Then I have to find my common ratio. My common ratio, to go from 4 to 20, I multiply by -5. And then if I multiply by -5 again, I do get -100. So that common ratio, -5, does work. So I'm going to go ahead and multiply by -5 to the n minus 1 power. This is my rule. Okay? And then from here, we'll go ahead and find the 7th term. So a sub 7 to 7th term, -4 times -5, and then it's to the 7 minus 1 power, and then we start simplifying to the 6th power. And then from here, we'll go ahead and use our calculator, okay? So we're going to go ahead and make sure we use parentheses because there is a negative involved, to the 6th power. So again, not only use parentheses, make sure we're doing exponents first. We hit enter, 15,625. Then we have to multiply by -4. Okay, and here's my final answer. So this is, to make sure you're doing these problems correctly, you do need to follow my steps in the calculator, okay? Because order operations is huge, and that's unfortunately where, when some people make mistakes, that's where it turns out to be. All right, we'll go ahead and do the rest next time I see you in class to make sure you really get this down. Thanks so much, and I'll see you next time.